Hello friends, welcome to the channel and good morning. So let's solve the Geeks for Geeks problem of the day. Make it a habit to solve Geeks for Geeks problem of the day, lead code, daily challenges and some more skills so that you will never forget competitive programming and data structures and algorithms. And also most importantly C++ because generally if you are a working professional then you would be either using Java or Python unless you are in a specific C++ role. So never forget to always do at least one problem from Geeks for Geeks or from Lead Code. And yeah, if you are keen to solve the problems, subscribe to the channel. I daily I solve the problems consistently, and once I solve them, I also upsolve them for my community so that they can get a better idea on how can we solve the problem. So now let's begin with the video. So today's problem is express as sum of power of natural numbers. So let's move on to the whiteboard directly. So we are given two natural numbers. We are given two numbers n and x. Okay. We need to find out the number of ways in which n can be expressed as a sum of the x power of the unique natural numbers. And as the total number of ways can be large, we need to return the module number of ways modulo 10 power 9 plus 7. Okay. So let's take the first example. So n equal to 10, x equal to 2. So I need to find the natural numbers, or I would need to find the number of ways in which n, that is 10, can be expressed as sum of powers of unique natural numbers. So 10 can be expressed, as the solution says, in only one way, and it is 3 square plus 1 square, that is 10, and this is the single way, and in no other way you can express 10 as a power of any other natural numbers. Okay. Again, let's move on to the test case number 2. We are given n equal to 100 and x equal to 2. Okay. Now 100 can be represented as 10 square. So this is one. Another thing is it would be represented as 6 square plus 8 square. Okay. And another would be it would be expressed as 1 square plus 3 square plus 4 square plus 5 square plus 7 square. Okay. So why I am doing the square? So that is very important. We are given a value x. Okay. And x can be, x ranges from 1 to 5 probably. Yeah, 1, and it could be greater than or equal to 1 and less than or equal to 5. So yeah, it is a pretty small number. So you can direct see initially why I took only the squares, because I am told that you need to express it as a power of x only. Okay. So 10 square, 6 square, 8 square. Okay. Something like that. Now if I take let me take one sample case, n equal to 1000 and x equal to 3. Okay. So the first case that immediately comes to your mind is 1000 can be represented as 10 cube, right? So this is one of the way. So in this problem we got three ways. Okay. We got three ways, and I know in this problem we can also get many more ways. Okay, but this is the single way. I am just letting you know the questions correctly. Okay, in this problem the x is 3, so that's why I need to take cubes of natural numbers. Okay, cubes of sum of cubes of natural numbers. So I hope you are getting this. Now again let's move on, how can we solve this problem. Okay. So we are given n equal to, let's say, 100 and my x equal to 2. So now based on the constraints given in the problem, it is told that n can be in the range of 1 to 1000. Okay. And my x, that is the power of a number, is in the range of 1 to 5. Okay. So this is what I am given in the problem itself. Okay. Now whenever you approach a problem wherein you will need to find the number of ways. Okay, number of ways or number of paths. Okay, or number of islands, something like that. Okay, something like that, some type of problems of like this approach. Okay, then what comes to your mind? It is recursion. Okay, see, DFS is a recursion only. DFS, depth first search, is a type of recursion. Okay, so the general umbrella under which this all problems fall is recursion. Okay, number of ways, number of paths, number of islands, and we have already solved lots of problems based on recursion. So first we try using recursion. Okay, then we move to DP, right? DP or memoization, top down DP, memoization or tabular. Okay, so there are two approaches again in DP. Either you can do solve it using memoization or you can solve it using tabulation, right? So initial thinking should go to your way that it is a recursion problem. Why? Because the number of ways, how would you calculate a number of ways? Yeah, you would either have to do some algorithm, you would either have some I would say partition algorithm, or you can use recursion. Okay, recursion. Now, based on the constraints given in the problem, we can clearly see that recursion would fit. I mean, recursion would fit. That means that we need to first try with recursion, and if it is getting time limit exceeded, definitely it will get it. Then we will need to optimize it to DP or memoization, right? So that is very simple. Now, how would you approach the recursive function? That's very important. Again, n equal to 100 and x equal to 2. So, what is recursion? Recursion means you try it all. Try out all. Always I say recursion means try out all. Okay, now I can start with, see, I would take one start variable equal to 1. Okay, now I can start with 1. Okay, I would take my 1. Okay, I would try to square it. What I would get? 1, right? I would try to square it. I am getting 1. So either I can, see, there are now two possibilities. Either I can take this one. If I take this one, now my new value n. Okay, now see, our goal is to, our goal is to make sum equal to 100, right? So somehow if we subtract from this number n, if I try to subtract from this number n, and if I make it to 0, then if I make it to 0, then also I am solving the problem only, right? Then also I am solving the problem. So it is either case, either you make sum equal to 100 or you make the number equal to 0. Both of them are the correct possibilities, right? So either I can take one. Now if I take one, now my new number would be 99. And either I would, and on the other end, if I, since I have taken my one, and we are told, see, when very important statement is unique natural numbers. Okay, unique natural numbers. So that is very important. So once I have taken one, I cannot take it again, right? So I would need to increment my start variable. So I am incrementing my start variable to 2 now, and x remains as it is. On the other hand, if I decide that I would not take one, okay, now I would not take one, and so my n value would still be 100, and I can, see, I am not taking one, then also I need to increment my start variable. Definitely I am not taking one. I am decided that I am not take one, I will not take one, so I would increment my start variable, and again x remains 2. Now following this approaches from each of the branches of recursion, I would get one answer, right? See, whenever I try the base case of recursion is very important. So this is the induction. This is the induction of recursion. Okay. Now, in the base case, if my n turns out to be 0, then I would return 1 or return true. Okay. So this is the base case of recursion. So I hope you are getting the problem. So let's simplify it now. We are given n equal to 10, x equal to 2. I am taking one start variable, initializing it to 1. Then I would square it, or whatever whatever is the power, I would do that. I have two possibilities. I can take one, I can remove one. If I take one, I am now, my new value of n is 9. My new value of x still remains, the power remains the same, and now start variable gets incremented to 2 because I have already taken one. On the other hand, if I do not take one, I will still remains, the sum is still 10. The x variable is also 2, and start variable also I need to increment because I am deciding that I will not take one, right? So now let me move on to the code. So I will live code it with you. So that is very simple. Okay. So as I told you, let's take one start variable starting with 1, because 0 square is 0 and it does not matter, right? It would simply increase our time complexity. So we are starting with 1, and I am calling one recursion function and x and start. Okay. So what this recursion function would return me the number of ways. Okay, int n, int x, and int start variable. Okay, so this is the case. Now what I told you, base case is very important in recursion. That would break your recursion. So if my n variable turns out to be 0, then I would return the 1. Okay, now I need to calculate the value, right? I need to calculate the power of power of start to the x, right? So what I will do, it is very simple. Again, I would take one sample variable value equal to 1. Okay, and I would iterate for int I equal to 0, I less than x times, right? We need to power the number x times. So what I would do, value equal to value into start variable, right? I hope you are getting this. So why, see, this is very simple. Why I am doing this? See, I would require 2 square, right? or 2 cube, let's say 2 cube. So I need to multiply the 2 into 2 into 2, correct? So that is 8, right? So I need 8, and I need to subtract this value. So this is my value and this I need to subtract from my n, right? So this is the simple problem for that. Now again, if my, see, I can break one more recursion. If my value here turns out to be greater than n, then there is no possibility I can take it, right? So I would directly return it 0 itself, because if my value is greater than n and now if I increment my start variable also, then also it is going to be greater than n, and it is of no use to me. Okay, finally I have two choices. First choice is that I take this value, I subtract that from the number, and I increment my start variable. Second option is I do not take, so my sum variable or n variable remains same, but my start variable gets incremented. Finally, the sum of both of the cases is what I need to return. Let me try to compile it. So this is the simple recursion code, and I tried to explain it to you in the better way. Now let me try to submit it. Okay, see, it is getting time limit exceeded. So as expected, it is getting time limit exceeded. Now, how can we apply recursion or memoization over here? So that is very important again. Now you have two moving variables. So always see, in while applying memoization, you need to identify the moving variables. Okay, or I would say repetitive or optimal substructure. That is what the technical term is. Okay, or this can be modified as repetitive tasks or moving variables. Okay, moving variables. So in this recursion function, okay, in this recursion function, what are the moving variables? I mean, what do I mean by moving variables? Moving variables means what variables are changing. So it is my sum and it is my start variable that are changing, right? So that too would be my dp parameters. Okay, so I would need to take dp 2d dp, and let me initialize it to 1000. Okay, and I also need to initialize it to -1. Okay, so I have initialized it to -1, and my dp variable is initialized, sorry, dp vector is initialized to d vector or 2d array, right? Now how would I check that? What I need to check, see, now what would be the repeated problems? Let's understand that. And some of the experts in dp may skip this, or some who have basic knowledge of dp can skip that. Okay, so n is 100 and my start variable is 1, right? So 1 square already I have calculated, right? Now dp of 100 and 1 is already calculated. Now when I move on to 2 or any other variables, right, I need not calculate this variable, right? So what I would do, simply, it is very simple. If my dp of, sorry, if we would take this case after this value, okay, if my dp of n and my start variable is not equal to -1, that means it is already calculated, then I would simply return that. I would not need to recalculate it again. And finally, while we calculate, and if it is not equal to, if it is equal to -1, then we will need to calculate it, right? And finally, when we return my answer, I would store it or I would memoize it while returning my answer. And also it is very important that we do modulus operation, because it is told that the values can go very huge. Okay, finally I would do dp of n comma start variable mod would be the result of my sums. Okay, let me try to submit it. Woohoo, it is getting accepted. So do not forget to subscribe to the channel. I would paste the code in the description, but always start with recursion, then move on to memoization. So that is the biggest tip for you. And if you have any doubts, comment it down, and do not forget to subscribe to the channel. Thank you for watching.